we are going to start the lecture on nanotechnology in chemical engineering. So, today we will discuss about synthesis of nanomaterials. So, there are many methods are available. So, synthesis of nanostructure or nanomaterial. So, today we will discuss about mechanicals methods. So, there are many methods are available. So, out of that, so we high energy ball milling. So, that methods and melt mixings method. So, that way we can these two are mechanical methods. So, these two will discuss in our today's lecture. So, we know there are various type of nano structure nanomaterials are available. So, we can means bottom to tops or top to bottom. So, that top down or bottom up method. So, we can use. So, here various type of structure, that is clusters, nano tubes, fibers, rods, films, polycrystallines, different type of materials are present, that is colloid, clusters, powder, tubes, rods, wires, thin films are present. So, if we can start it from the precursors, or we can start with a bulk polycrystalline material, bulk materials from there by making them into smaller nanostructure materials that we can prepare. Okay. So, here also means spin coating method, template method, electrospinning, many way also means from gels to we can form films, nanowires, nanotubes, nanofibers, this we can form. That way means by following a particular methods we can prepare many types of nanomaterials. So, here's many methods that are available to synthesize different type of nanomaterials, means here I have shown different type of structure, means nano materials that is are available. So, a particular methods we can use. So, many methods are available. So, existing methods are available, so that we can follow, and once that methods means modified or updated some special features. So, then that is more advanced, means that techniques. So, that techniques also we can use means to synthesis a particular materials. Okay. So, depending upon our the type of materials, means whether it is 0 dimensionals or 1 dimensionals or 2 dimensionals, a particular techniques we can discuss. Okay, we can prepare. So, I said the synthesis methods that may be physicals, chemical, biologicals or hybrids synthesis methods, means any ones we can follow depending upon our preparations, means from where we are going to start. So, here in physical methods, mechanicals or vapors methods. So, here physical method high energy ball milling and melt mixing. So, this particular method is very useful, means for industrial scale or industrial application, means bulk scales material preparations. So, in this we will discuss, and later others different methods also we will discuss based on evaporation methods, sputtering methods, electric arc deposition method, ion beam techniques, molecular beam epitaxy or CVD methods. So, these are the things we will discuss later. Okay. So, let us start about the mechanicals method. So, in this is called high energy ball milling methods, or here you can see the device is here. So, here you can say it is a planetary ball mills also. So, this methods is cost effective methods and means to produce a particular materials or nanomaterials, means here actually we start with bulk or large scale materials. This is the large bigger particles we can say. So, from here we can make it into smaller particles by using high energy ball milling methods or these methods. Okay. These methods very simple methods of making that particular nanoparticle. In this particular methods we have to use ball mill and a cylindrical chambers. Okay. So, in cylindrical chambers we have to use the starting materials. So, whatever the materials you want to make it into nano range. Okay. So, this is bulk materials. So, that we have to place in any cylindrical chambers, and then we have to put some ball. Okay. That ball may be tungsten carbides, that ball may be aces, different depending upon that applications or our availability. So, that particular material balls we can use with that materials, and here's this is jars you can see. So, the jars we can depending upon the quantity of materials we are preparing. So, number of jars, number of balls we can consider or we can take in a containers, and then we can start the grinding. So, there also sometimes we can use solvents also, sometimes we can use inert gases also. so during grinding, so depending upon our applications. Okay, so here inside I said our starting material is present here, and with that few SS steel balls or tungsten carbide balls we can use. So that balls will rotate inside of that chambers. Okay, and then in frictions or collides with that balls and the materials, so there is different type of deformations stages are there: elastic deformations, plastic deformations, shear deformations. After that, that molecules, these crystals or larger particles will changes into smaller particles or smaller molecules. Okay, so here these type ball mills we can classify four different types: planetary ball mills, tumbler type of ball mill, attritions ball mills, and vibration type of ball millings. Okay. So here in planetary ball mills you can see this is planetary ball mills. See here's either 2 jars or 4 jars we can placed inside of that milling process. Okay. So here 4 jars were taken. So 4 jars in here is the disc. Over that disc that stainless steel jar was placed, and inside of that jar balls and the starting materials we have taken inside here. Okay. So in tumbler types also, here's this is tumbler types arrangements, and here attritions ball milling. So here's the details we'll discuss. So this type of arrangements and vibrations ball milling. So that is also inside of that jar we can take balls, and then with the vibrations means horizontals, three dimensionals. So depending upon that materials and balls will be interacts, and then size reductions will be there. Okay. So depending upon our amount or quantity of the material, so we can change the size of the containers 100 ml, 50 ml to 1 liters, or bigger size also we can consider depending upon our size, means amount of the materials or quantity of the materials we want to prepare. Okay. So here's the four different type of ball mills we can see here the picture. So now we'll discuss about the planetary of ball mills. So in the planetary ball mills, I said it is mostly lab scale study. Whenever we prepare a very small amount of the samples in nanoscale, so then we can use these planetary type of ball mills. Okay. Here I said either 2 jars we can use, or more jar we can use, or single jar also we can use. That would the jar will rotate around the axis. Okay. So once it is rotates, so I said some grinding balls we have to use. They will interact, and then due to the different type of force, means balls and materials interacts, and then they will convert it into micron size, less than 50 microns or 10 microns. That type of materials or particles will forms. Okay. So here in this case in planetary ball mills, usually the balls and materials ratio that is very crucial. So number of balls we cannot consider any number. So usually 2:1 ratio that is kept. So also it is we can change depending upon our requirements or materials quantity. So containerage means more than half filled, then efficiency of milling will be reduced. Means here's the containers, means the jars we have taken, there's balls and materials ratio very low quantity or less amount you have to consider to get a reduce the means size reductions. If you want to get a good very small size and good amount, so then we have to means containers means too much amount of balls and materials we cannot consider, we cannot take. Okay. So here's heavy milling balls we can use, larger balls also we can use, means that materials I said with that the balls we have to use, the balls may be heavy or maybe bulk or larger size. Okay. So when it is heavy balls, it increase the impact of energy on collisions, hence that balls and materials will interact. So heavy milling balls that increase the impact of the energy on collisions, different type of collisions that I said. So when it is large balls, then produce smaller size of smaller grain size. But however here some problem is there. So means larger balls they will interact with each others, and then some impurity will be contaminated with that materials, ball itself will interact with each other, and then some impurities due to these balls that would be contaminated with the samples, that is the disadvantage. So, using larger balls we can get smaller grain size of the particles, but there is some disadvantage too. Okay. And I said that containers whatever we are using, balls and materials, this is also means filled with some inert gas also. Inert gas, when grindings will be there, some inert gas, nitrogens or maybe hydrogens we can use, or argons also we can use depending upon our applications or that materials we are going to size reduce. Okay, size reductions, then we can use. Also this is gas, also we can use some liquid also, liquid as a solvents also during grinding. So, as a grinding mediums we can use. Okay. And also when that grinding is going on there in that inside of that bowl, so then the temperature also increase 100 to 1000 degrees centigrade, that depending upon that how long we are means rotating that bowls in that particular millings. Okay. So, in high temperatures, when the temperature will rise during milling, so that has some disadvantage, agglomerations would be there, and low temperatures it is means desirables, means when we are doing the milling, so low temperatures amorphous type of particles formations is there. Otherwise, if it is temperature increase during that milling process, so then agglomerations and larger crystallized types of larger particle formations is there. So, that also we have to keep in mind. So, when we are going to means synthesize any materials using planetary ball mills. Also I said temperature rise is there, that is one thing. So, sometimes we are use cryo cooling, that is also used, whatever the heat that forms during that process, milling process. So, we can remove or we can dissipate the heat that would be generated by using cryocoolings from outside. Cryogenic liquids we can, liquid nitrogens or other things we can use, or any chillers we can connect with that. So, that is special type of cryo millings. That way also we can down the temperatures, that way we can get amorphous or smaller micron size of materials. Okay. So, here's in the milling process. So, I said that here black one, that is materials, and rest this part is the empty. Okay. So, the amount of the materials, balls and vacant space, that is very crucial, and depending upon that the material property also will change. Okay. So, now with this planetary ball means many materials, means mixed metals we can do the size reductions, sometimes alloy formations also we can do with the help of this type of ball milling process. So, in this ball milling process we can prepare depending upon size of the jar or balls, we can prepare milligram amount, means very small amount lab scale materials, to industrial scales kg amount, means 1, 2, 3 kg of materials we can prepare nanomaterials. So, depending upon bowl size, quantity means small to larger quantity we can prepare. Okay. Next horizontals, this is the planetary ball mills. Okay. So, now is coming to tumblers type of milling process. So, here's the bowl or this jar would be in horizontal, means horizontal way that would be placed, and so balls will rise and then falls over the materials, and by that way some force will be developed, that is will be interact with the during this process, and that would helps in grinding process. Okay. So, impact and attritions both will combine, and that will force will be generated, and that would be assist to reduce the size of the particles. Okay. So, and then next is the attritions type of ball milling. So, in attrition types of millings, so generally ball will be stirred. Okay. So, this is the stirrer is there, that will start the ball or attach the ball, attach the ball. So, rotations, the shaft will rotate, and due to this means cylinders also rotate, cylinder will be fixed here, and this stirrers or that will or that shaft is there central, at this central shaft is there, this shaft will rotate, and then balls will also moves, and then there is some interactions with the balls and materials, the size reductions will be there. Okay. So, in this case the cylinders outside that is remain fixed, that is not rotate. In case of planetary ball mills or tumbler types, their cylinders or that bowls will be rotated, but here it is fixed. Okay. Next, vibratory type of millings is there. So 1D vibrations or 3 directional vibrations is possible. So in this container or bowls, here balls and materials will be placed here, and after that some oscillations, some programs will be set, and that way it one directionals or 3 dimensionals vibrations will be created, and with that vibrations that materials will interact with the balls, and then size reductions will be there. Okay. So here in case of 4 different type of milling process I have discussed. So now in case of the planetary ball mills, that is mostly lab scales material preparations it has been used. So in case of the planetary ball mills, so there are many factors that would affect the milling process that I said. So type of mills, so low energy or high energy mills, size of the container bowls or vials, that is also important. The materials of the millings, materials of milling means the balls we are taking, that may be tungsten carbide, SS, steel type alloy or ceramic type of materials we can consider for milling process. Okay. So shape of the milling medium, so here the balls or rod types of we can consider. So mostly balls types of use as a milling tools. Then is the ball to materials ratio, the materials and balls that would be taken inside of this bowl. So its ratio is also very important. Milling speed is also important. Milling times, how long we are milling, so that is also very important. So we mill it for short period of times, 1 hour, 2 hours, or we can mill it for 24 hours, 2 days. So but depending upon milling time, so if we increase that milling time, so then very smaller size of particles will form, but at the same time contaminations will be more. Okay. Sometimes balls will interact with each others, and then ball contaminations might possibilities there. Then milling atmospheres, inert gas, reactive gases that we can use, or we can use some solvent, or we can without any inert gas or solvent also we can use, that is called dry or wet type of milling. Milling temperature I said, milling pressures. Okay. So these are the things. So here, so some other factors also when we use means this speed of that bowl depending upon that rpm. So rpms we can set, that would setting that rpms, its speed also will change, if it may be low speed, high speed, or maybe a sufficient in between that speed. So when it is low speeds, then attrition force will affect, that will play to reduce the size. When it is high speed, impact forces is there, that would assist to mean size reductions of that particles. And when sufficient speed is there, neither very high neither low, so then a centrifugal force that would helps to reduce the particle size. Okay. So advantage of planetary ball mill. So here I said it, we can prepare the materials by dry or wet ball millings way. So batch or continuous, the process batch or continuous operations, batch process or continuous way also we can prepare the materials. Here in this particular methods, so there is no burning or effect or any means whenever the materials if you heat it up or size reduction some other way, contaminations, burnings, other things possibilities there. So that thing we can avoid, that type of harmful effect is not seen in this type of operations. Installation or operation labor cost is very low. It is better to use for fining, grinding, abrasives or hard materials, and high capacity and universality. So this is way means we can, I said milligram to kg amount of quantity we can prepare that materials, and at the same time maintenance cost is low. Long term maintenance of the specified milling speed fineness by a certain capacity with a periodic supply of balls to compensate for wear. So maintenance also is very easy. Okay. Some disadvantages there. So the process is destructive, destroying the crystal structures, hefty weights, that system's weight is very high, and grinding use lot of energy, means when the process is continuous always you have to run that bowls or bowling rotations is there. So electricity cost means grindings lot of energies is there, heat loss is there, means materials will be heated up during ball millings, that also energy loss is there. Also I said contaminations, noise is present, contamination from the ball with the materials that is present. At the same time, when grinding used to be there are a lot of sound vibrations sounds also would be there, so that is also disadvantage. So next is the melt mixing. So this is another mechanical method, so that way also we can prepare nanomaterials or nano composite materials. So here we will discuss. So here suppose is solid materials we have. So if we increase the temperature, so initially it was crystalline solids. So when it was initially it was crystalline solids, when we change the temperature, suppose a solid materials we have considered it is in high temperature, so it is in melt state. So after that if we gradually decrease the temperatures, so initially this is the melting temperatures or Tm, that is the temperature, certain temperature a particular metals or materials that would be converted into liquid state. Okay. So after that the liquid will be cooled, means temperature will be down. Okay. So then what would happen, that would be solidified. So here's the rate of cooling is very important. So here if we cool that material, so then it would change its structure from crystalline or amorphous, both the types of materials it may forms, means whence that metals we cooling down, metals would be liquid state to the solid phase, that would be converted. So once that solid to liquid to solid state formations would be there, so the material formations may be amorphous or crystalline, both the types. Okay. So either we can prepare amorphous types or crystalline types. If we cool down that liquids very fast, so high rate of cooling, so then it is form amorphous solids. Okay. Or that is called glass transformations within that regions. Okay. It is fast coolings. Okay. So when we are cooling is fast, then glass transformations or amorphous type of material formation is there. And when it is slow cooling, so here slow cooling, so in that case crystalline type of materials formations is there in case of the slow cooling crystalline material, and when it is fast cooling, so then amorphous type of materials formations is there. So means cooling effect is very important to means depending upon interest whether it is amorphous or crystalline materials we are going to prepare from that particular means substance or solids that is heated up at high temperature and then cool down. So there is also another advantage. So when we made that materials into high temperature and melted into liquid state, there are other elements also, boron, phosphorus, silicons, these are the elements also we can mixed up, and then mixed means contaminated, means as per depending upon applications we can make them. And then if we down the temperatures, then it would assist this type of elements when it's present, say amorphous state formations would be much more easier. Okay. So here means melt mixings, when is there some polymer matrix formations. Suppose here's we are using some, let's say this is polymers and this is nanoparticles. With the polymers some nanoparticles also mixed with that, and then we can get the mixed materials. Okay. So means polymers that is mixed with nanoparticles. So the nanoparticles may be nanoclay, nanotubes, or any metal oxides or metal sulfides, any materials that we want to mix up or distribute in the polymers depending upon applications. So we can mix up melting at high temperature, and then they will be mixed up, and then a homogeneous mixtures will form polymers and nanoparticles. Okay. And then if we are rapidly cooling down or depending cooling down temperatures, means if we rapid cooling, then amorphous type of smaller particles formations is there, or if it is slow cooling, then crystalline type of composite materials may form. Okay. So another type is there, that is very thermoplastic polymers, and different type of nanoparticles disperse. If we do, suppose here this is polymers that we have taken here and it is heated up, and then some nanoparticles, this is nanoparticles mixed up. This is the conventional lab skills we can do. So then we can melt blending methods, this is called, and then if we cool downs in ice bath or any down the temperature, then the materials will be a composite materials we can form. Okay. So it has many applications, means these melt mixing methods, lot of applications is there. So means this mixed materials we can make a thin film formations. Okay. Depending upon our applications, means photovoltaic cells, display device, optical data storage system, or bioimaging. Many applications are there. So depending upon that particular materials that we want to use for that particular specific device's purpose. So this way film formations also we can means polymeric materials and nanomaterials both we can mix them up at a particular temperature, and after that by pressing we can make them into thin films. Okay. Another one is the glass formations, that is silica or silicate, that is glass, it is made of this. So depending upon that type of applications, so if we means suppose we have a window glass, it has silica into calcium, magnesium, or this is at different percentage. Also we have a laboratory glasswares, it has this compositions, or color glass, if we add less than 5% of any this type of cadmium sulfide, titanium oxide, zinc sulfide, CD, AC, so semiconductor type of materials. So depending upon a percentage, so different type of glass we can mix by this melt mixing process. Okay, thank you. So today is up to this.